Hello users of YouTube and welcome to yet a new episode of Daniel's Videos and etc. Today we are going to be repairing this refrigerator. Alright, back to the show. Alright, so guys, hello and welcome to this new episode of Daniel's Videos and etc. And today we're going to be taking a look, like I said again, at the refrigerator. And there is nothing specifically, or no, actually there is something wrong with this refrigerator. And I basically, the main idea for this repair project is I want to make this refrigerator my film refrigerator. It's your basic cheapo refrigerator. So basically how it works is, whoops, the back just fell right out. Basically how it works is you have this refrigerator. I don't know all the science that goes into it. I just know that, so basically inside there's nothing except for these 4 screws back here. And those 4 screws hold a heat sink in place. And there's a fan that blows on that heat sink. And that fan, I don't know, somehow it just creates cold air. And it gets it down to supposedly quote-unquote 32 degree Fahrenheit. So, yeah. The fan in this, though, has started making noises like crazy, and it's been doing it nonstop. We're going to plug it in here in a moment, and I'll show you guys what I mean. But we actually do have a nice fan we're going to replace this thing with, and it's a Cooler Master 80mm fan. This is the Cooler Master 80, I think that's a 5 or an S, 80ST2. I think that's what it means, 80ST2. And it spins at 2,000 RPM, it's only 20 decibels, and it's good for 50,000 hours. And this is going to be running continuously, so we will see. So here are the specs. It says back here that it features higher airflow to enhance cooling performance, silent operation for case cooling, and ROHS compliance. Here's the specs. Fan size is 80 by 80 by 25 millimeters. Voltage runs at 12 volts DC. Current amperage 0.10, give or take 0.01. Input wattage is 1.2 watts, give or take 10%. Span feed is 2,000 RPM, give or take 10%. Airflow is 28.89 CFM. Air pressure is 2.24 millimeters. High water. Yeah, on the dick. The noise is rated at 20.9 decibels. Weight 62 grams. Black. The bearing type in this is a rifle bearing. 50,000 hours. It has a 3-pin connector on it, and the 3 to 4-pin adapter, which converts it from the 3-pin non-PWM to Molex connector, and 4 screws. And this fan, the box is dated 2006. The picture on this is for reference only. This is not actually what the fan looks like, but it's kind of similar. So, yeah. So anyway, we got our fan. And, yeah. So we're going to open the fan up here. So, yeah, we open up. We got some screws. We got an adapter. There's the Molex connector to the 2 pins. Pretty much, yeah, very simple. So you can use it in a computer or something that you don't have enough pins on here. And here's the actual fan. So at least I'm using an actual name brand fan, which is good. Now, the fan in this refrigerator always constantly spins, and it only has 2 pins. So the yellow one is what tells the computer how fast the fan is spinning. And that's the point of this yellow one. Unfortunately, since this thing doesn't use that third pin, we are going to be trimming this off, and I'm going to be closing it up with a heat shrink tie, and I will not be recording that part for it. The main goal is to get the ground. We got to trim off that connector for this. It's not going to be easy. I have to solder it. So trimming off the yellow, and we're keeping the red and white, black and red, and trimming it up a little bit so I can solder it onto the controller board here. You see, I just need a place to cool my film when I'm not using it, because I really don't take pictures a lot, and a lot of the film I have expires pretty soon, and I want to kind of keep it up a little bit more. So yeah. Alright guys, I'll show you this powering up, and I'll show you the noise it makes. I'm going to go ahead and plug it in here now. So basically it takes two connections, and this is pretty neat. It takes DC 12 volts and AC 110 volts. So it can run from the car, or it can run from wall. And funny thing is, the fan is rated for 12 volts, so this is probably directly to the fan. I mean, the only thing mechanical in here, and this is pretty much the only reason why this thing exists, is for the fan, and that's the only thing mechanical. So I'm going to switch it to AC mode, and I'm going to hit the cold. So if you hear that, that's coming from that fan. Yeah, you can see that. That fan's going bad. And it's slowly slowing down. I'm not going to torture it any much more than it has to. So that's basically what the problem is with the fan, and that's what we're going to be replacing it. And we're replacing it with that beautiful Cooler Master. Alright, so let's begin. I already removed the screws off of it. Here, if you want the guys to buy this refrigerator, this is a Coca-Cola refrigerator. And, well, there are the specs for it. If you need it. It's manufactured by Coolatron, and it's branded specially for Coca-Cola. I believe they sell this refrigerator on their website still. Yeah, so nothing special about it. But yeah. All right, so I already removed the screws to the back of the thing. So all I have to do is just kind of lift it up. And let me get the screws out actually. We have 3, 4, 5, 6, 7. Crap, where did 8 go? Oh, there's 8. 8's back here. And there's the 8th one. There we go. So now I've got all the screws out for the back plate. Let's go ahead and continue taking this. Right, so on the back side here we got the fan. I'm going to go ahead and show you guys, get a close-up of the fan. Flip it around here. So the fan, manufactured by a company that doesn't actually have a website anymore. I think they still exist. This fan is a YEF fan model FD800-220. I'm sorry, model FD8020SH. Runs rated at DC 12 volts at 0.15 amps. I believe this is a Japanese company. I'm not really sure, but they have a website on the top here. You can go to www.yerfeng.com. I went to their site. I couldn't. The site didn't exist, so I don't know if their company is still around. So we will see. So I'm gonna go ahead and take apart the fan now. Not take it apart. I'm gonna unscrew the fan from the refrigerator's base. Now what I could do, make my life so much easier, is I could cut the leads off for the fan right here and solder and kind of just resolder the both wires together. but I don't know if I don't think it'll make a very clean connection. It will save my work a lot, as this is not very easy looking at all, as all the wires here are clipped together and whatever. So alright, here we got inside. Here's the heatsink I was talking about. And don't worry, you're not missing much, because that's all in here. That's all electric. So you have the controller board back here, power supply, and then the fan, and the heatsink for the refrigeration. And it's really dusty. I could blow that off too. So let me see. Everything is zip tied together, as you can see, all the wires and stuff. So I'm gonna see if I can pull this apart and find. No. So it looks to me like all the screws that hold this board together, they are all right underneath this sticker. That is very sad. So I think it'll be easier if I just went through the cheap way and just kind of cut these two wires right here, splice them. Yeah, I'm gonna do that. It's gonna make my life so much easier. So here's what I am gonna do. So updated plan. Taking the fan, I'm cutting the wires from it. I got my wire cutters here. So we're gonna cut these wires, and then we're gonna solder the new fan to it next. Alright. So I don't have any safety goggles at the moment. I'm gonna be careful with this. So I'm gonna cut both of these wires right off. That wasn't too hard. There we go. Now I'm gonna splice them. Wow, this is a very nice wire cutting thingy. Right. Okay. So there we go. I just cut our old fan right off, and all the wires. So yeah, it's made in China, where all the good Holga products are made, as I say. And that is true. So there's our old rotten fan, and here is gonna be, I don't know, I might use the screws that came out of the old fan to fit in the Cooler Master, because the Cooler Master fan uses quite a bit thicker screws, and that's what I'm kind of worried about, as the screw holes on this are very tiny. So that is what I might do. These wires are really thin. Alright, so here's our Cooler Master fan. I'm gonna go ahead and see if this works. I'm gonna hook this up directly. I'm just gonna run. This is gonna be really bad bodge. Here, I'm just gonna make sure the fan works. I'm gonna plug the fan in directly into the holes. Don't try this at home. 12 volts may not kill you, but it certainly can if you're not careful. Alright, so I got the fan plugged in. I'm gonna go ahead and hook this up directly, and you see if this fan will work. So you guys will see the fan spin up. If it does not, okay, I'm switching it on. It's blowing. Huh. Very quiet. So yeah, the fan is spinning. And the fan just died. Ah, connection got loose. So, that looks pretty well, actually. It's blowing, it's actually blowing pretty well. I'm surprised it's pretty fast, actually. So that's pretty neat. So we know that the fan works, that's great. So we know that the fan works. That's awesome. So this fan does work, and that is pretty great. So I'm going to go ahead and splice the old wires here for the old fan, and I'm going to see how that compares. So I'm going to resplice the old wires onto the fan here. Check out the comparison. see of the speed difference. I still have that memorized on my hand. Hopefully I don't kill myself in the act of doing so. Alright, there we go. Alright, plugging it back in here, switching it on. It's definitely a lot slower. So the old fan spins slower than the new one, or faster. And this is rated for 0.18 amps. Actually, it doesn't sound too bad. So yeah, this fan does spin a lot faster than the new one does, which that stinks a little bit because yeah, many reasons it's not going to be as a great performer than the Cooler Master, but nonetheless, oh well. I think it'll do fine. If I won't do too bad. Genuine Cooler Master. Interesting. There's a hologram on the fan. So I'm gonna cut the wires now and splice this up here, and we'll get back to you guys. Cutted the wires. It's a little too short, unfortunately. Could have made that longer. Alright guys, I'm gonna be right back here. I'm gonna go ahead and heat shrink this wire right here. I'm gonna heat shrink that. I'll be right back with you guys in a moment. Alright guys, I got that got that right back on there, which is great. I'm gonna go ahead and get some thinner sheet shrink. Now to cut the connections here for the new terminals so I can use this fan. Alright folks, so here's what I want to do now. I'm going to take those new wires I just tied together, I'm going to solder them together. So that's what I'm about to do next. So you guys are going to be seeing me solder next, so I'll be right back in a moment. Alrighty people, I just got the solder on. So I'm going to go ahead and start soldering here. Alright folks, I think that's good enough. Alright, be right back guys. I'm going to shut off the iron here and we'll come back right to my carpet. Alright guys, now reporting back to the carpet. Let's see if this was a success. So I'm going to go ahead and plug this thing back in and we will see if it powers up. Cool. Alright, so now we got it hooked up. Alright, let's go ahead and do that. The wire is quite a bit shorter. Made the silly mistake of cutting it too short. I could screw it in this way. Right? So I'm going to use the screws that originally came with the old fan, which don't actually happen to fit the holes of the Cooler Master, which is okay. Whoops, what happened to it? Almost fell to certain doom. And of course you guys can't see whatever the heck I'm working on. Alright, so I'm going to get the heatsink while I'm here. I'm going to get my hurricane out for a second. Give me a moment. Alright, back. I'm going to go ahead and start blowing at this thing. Alrighty, I dusted it out. So now I can put the top back on. So look, not too bad. Interesting. I don't know if I've noticed this. There are actually some wires going under that heatsink. Right here. I don't know what that is. But that is interesting. Alright. So that wire, yellow wire I cut, will remain hidden for thousands of centuries. Alright. There we go. I'm going to go ahead and screw the top and the bottom. And I'm going to power it up just one more time to make sure it works. Alright, I'm going to plug it in the refrigerator here. And turn it on. It is a lot more quieter. It is spinning. See if it's getting any cold. Oh, I can feel cold air. Alright folks, we will see if that gets any colder. I will be sticking a thermometer in there to find out. So, there's how close the fan is to the heatsink. And yeah, I'm gonna screw in the back a couple of screws, and I'll tell you guys if this was a huge success or not. I'll report with you guys in the next 30 minutes or so and just see how cold it has gotten. I'll check back with you guys in a moment. Hi all members of YouTube yet again, and I am in my stereotypical kitchen like in my algebra project, and here is what I'm going to be using to test the temperature out on the refrigerator, whether or not it works. I have the refrigerator plugged in right here. That's great. So basically I'm going to take this thermometer gauge from Oregon Scientific, stick this right in here, close the door, and I'm going to let this thing run for 30 minutes. And I'm going to see if that big temperature drops down. So right now I'm letting the temperature reach equilibrium on that receiver, on that transmitter. Right now it is 73 in the house, and I need to get it to 73, or at least within 70 degrees. So I'm letting the thing reach equilibrium to the temperature. So I will start recording once it has reached a good point. Alrighty people, I finally reached equilibrium. 72.9 degrees, close enough to 73.6. So I'm going to go ahead and take this device and put it in the refrigerator here. Shut the door. Oh, by the way, this did come with a shelf that goes on here. Basically, I can put the shelf back in and then put my film on the second shelf if I wanted to, and then maybe keep a couple bottles of water down here if I wanted to. More on that later. So I'm going to switch it on here. Basically, I'm just going to relax on the couch and watch and see if this goes down. Starting the timer for 30 minutes. So we will check back in 30 minutes. Alright guys, I'll see you in a moment. Hello guys, I'm back 30 minutes later. Here we go. According to this, the temperature started at 72.9 degrees and it started dropping down. The next 5 minutes later, 72.7. 10 minutes in, 69.8, 15 minutes in, 66.9, 40 minutes in, 63.9, what am I saying, 40 minutes, 20 minutes in, 63.9, 25 minutes, 61.2, and toward the end, 59.2. So, the temperature went down about 13 degrees, 13.7 degrees, so, and it's still going, 68.8 now. It's getting colder. I'm going to let it run for another 30 minutes, but I'm not going to keep an eye on it. I'm just going to do 30 minutes track, and then 15 minutes track, and then 0 minutes track. So that's what the next set are going to do. So I'm going to begin the timer now, and tell you guys in a moment, and we'll see what happens. Alright guys, here I am yet another 30 minutes later at 52.9 degrees. Temperature didn't really drop that much between the start of that. as you can see here, it's only dropped about, yeah, it's about 6.1 degree drop, I believe, or it's 5.9, 5 point, I don't know. It did drop about 6 degrees roughly, 5.9, I guess. Oh, I don't know. Anyway, 6 degree drop roughly, and it not very good compared to Bat 11, that 12 degree drop from 30 minutes to 0. This is about half that. So it went from 12 to 6. So I'm assuming the next 30 minutes are going to be from 6 to 3, and then 1.5. So it looks like it could get about down to maybe 49 degrees, which is pretty cold actually, which is not too entirely bad. As it says 42.9 on here, it is slowly going down still. It's now 52.7. So 52.9. I'm gonna let go for another 30 minutes, and if it still hasn't gone any lower, I'm just gonna start it now, see what the time is, or the temp now, and then end the temp at the end. I'm not gonna do a halfway mark. Alright, so now I got that in there. Now I'm gonna start the timer again for yet another 30 minutes. And I will check back in you guys for another 30 minutes. So see you guys in a moment. Alrighty people, so with this new fan in it, the lowest the refrigerator got was about 52 degrees Fahrenheit. And when you open it, it is pretty cold actually. But the lowest it got was 52 degrees. So not too bad. I think it could have done better, but 52 degrees is better than nothing. And it is pretty cold in there too. I think that was how cold it got before. I mean, before this was a film refrigerator, or was going to be one, it used to be a beverage refrigerator. Back a couple years back, I used to use this for storing cold bottles of water. I used to put 4 bottles of water in here, and it would take about 3 days for them to cool very well, like very cold. And not icing, just very cold. So 53 degrees. I just opened it up, so of course there's some warm air must have gone in, but 52.0 is not too bad. Alrighty guys, the refrigerator repair video is now completed, or the refrigerator repair is now complete, which is great. So I got this Coca-Cola machine back in okay order. I mean, it was working before, it's just the fan was making really irritating noises. And I added this new Cooler Master fan, which is kind of funny. You don't typically see Cooler Master fans in these kind of products. I checked up the price of this refrigerator on the internet. It's about 50 bucks on Amazon. Specific ones got like 7 reviews. It's like 4 stars. And this refrigerator is pretty good. It served me well for these past years. It's a basic refrigerator. And all it is just a fan on a heatsink. And yeah. Anyway, I got it in restored order. So it's working again. I'm going to use this to store film. Pretty much, I'm going to see if I can find the top shelf for this. So that's where I'm going to put my film on the top shelf. Maybe I'll buy some soda, or maybe some Sprite or something. I might stick it on the bottom. Or maybe some small bottles of water, and I'll stick those at the bottom of the refrigerator. Just to kind of enjoy. But yeah, that is it. Alrighty people, I found the shelf for the refrigerator. Simply just slides in right here. These guide rails. Up. Come on, there we go. Very simple. So I'm thinking I'll just stick all my film on the top here, and then maybe leave some room for some other film at the bottom. So yeah. Alrighty guys, here's the refrigerator. I put it on here on the shelf. Maybe I might pull that in there, why not? I already kind of moved everything onto this part right here for the remainder of its life, or until I decided to get rid of it. Here, hold on, let me swap these guys out for a second. Alright, I just swapped the M&M's guy out for a little ceramic thing. Yeah. I might move him again because he's blocking Windows 95. A sealed copy of it. Anyway, I just moved it over here. Yep. So we can switch it on right here on the side. So here are all the settings. You have the 110 volt AC, which is for the outlet and no ground. Car, this is for powering it from the car. DC 12 volt, a switch for AC to DC, and then there's 3 switches. The stop, it goes, just turns it off. Cold, Freud, which is green. Freud is French for cold. And chaud, I think that's chaud, is French for warm or hot. And arrête, yeah. Arrête, I believe, also means stop in French. And the red LED means that setting, and the green one means cold. So here is, if I switch it on to warm or hot, the red light turns on, but if I switch it to cold, the green light turns on. There is the remains of the speed information wire, which tells the information of how fast the fan is going. That's what's left of it. See, it's kind of heat shrunk. So if opening the door just clears that, so I get full access. These are been screwed on. That's a sign of good engineering. To keep the air from rushing out, you got these rubber pads. It curves this plastic bezel, which keeps the cold air from coming out. But yeah, there's no light inside, which is alright. It's a basic refrigerator, not much to ask for. But we're going to put our film in. So I got my arista.edu 400 ISO 120 film for my Holga. Stick that in on the side. Reason why I have Arista rather than Kodak is because this film is cheaper than Kodak, thankfully. And Kodak film is expensive. This I can get $15 for 5 of these. And Kodak, a 5-pack of the black and white T-Max film or something like that, that's like $23. It's ridiculous. Whoops. Dropped some of my Agfa Rolly film. I got my Rolly color negative, color positive film, or Agfa. I don't know what you call it because there's many names for it. All right, let me put, and then I got Holga black and white film for trying that out. So Arista is also what we use at school, so that's why I have it as well. So I won't have enough room to fit the Fujifilm, so let's see if I can fit in the back. Cool. Maybe I can move all the film to the bottom here and then put some bottles of water on the top, and then all the water might leak down on it though. Oh well, I think this is good as just a film refrigerator. I think I can store up to 5 of these Fujifilm boxes. I think about 5 or 4. Not too bad. So there, Fujifilm fits perfectly in there. So the reason why I got this refrigerator up and running is mainly because of the Fujifilm, because I bought it and this is the expiration date. It's 2015 of September, so it's already 2015. This film's got 7 more months to live. So this is one of the reasons why I decided to do it too. And I gotta be careful, protect from heat. If this thing starts malfunctioning, this refrigerator, well, goodbye film. Joking. Alright, so I got all my film sitting on the top here. And I got my color positive film sitting there. I'm gonna keep some spools in here. Keep some 120 spools and cold and whatever. Why not? I got so much space. It's almost hilarious. Alright. It's kind of cute looking. I don't know why. I just think it is. I use all the used Agfa rolls. I use those for storage of used black and white film because why not? I'm gonna probably keep these out here because I don't need them. Right. So, alright people, thank you for watching my repair video on my new film refrigerator. Thank you for watching, people. Yeah. Oh, by the way, one more thing. When this thing eventually gets up to speed, the fan, I don't know if it's the fan or just the refrigerator's design in general, but it's really hot and it smells odd. It smells sort of like it's burning, but it doesn't at the same time. It's kind of a weird description. But I looked on the internet and it says that heat dissipates from the refrigerator to keep the food inside fresher longer. I don't know. I mean, I think it's supposed to be normal, but what's kind of scaring me is I put it in a new fan, and it's got a little bit different specs than the one that was already in here. So that scares me a little bit. It's like it smells like it's burning, but it doesn't. I don't know why. It's weird. But anyway, thank you for watching my refrigeration repair video, guys. Now my film can stay fresher longer. Thanks for watching, guys. Like the video if you liked it. Dislike if you hate the heck out of it. Something I've been wanting to get done for a while, and I finally finished it. Again, guys, thanks for watching, and I'll see you guys in the next one. And leave a comment below if you have one. Alright, guys, see you in the next one.